Hello everyone, my name is Aman and today I am making this presentation video to tell you all about what I learned in this internship which is provided by Emertxe Technologies Private Limited, which is based in Bangalore. This is an IoT internship. So I am moving forward with what I learned during the internship. So first of all, I have learned about the C and C++ programming language. After that, I learned what is embedded system, and after that, what is IoT. And in this internship, I have also created a project which is IoT based home automation system. And today I am demonstrating this as well after the PPT. So introduction to C and C++. So basically C is a general purpose programming language which is created by Dennis Ritchie at the Bell Laboratories in 1972. C is an old language, but it is very popular among the youths or the tech enthusiasts as it is connecting to the hardware. Whereas C++ was middle level language and it was developed by Giant as an extension of the C language. Both of the languages are very most popular languages in the world because they are powerful, efficient and versatile, which are making them essential tools for a wide range of applications, from system programming to the game development. After that, about the syntax and the language fundamentals of both the languages, C and C++ have strict and well-defined syntax, which can take some time to master. Both languages offer a wide range of data types, from simple integers to floats to more complex structures like arrays and pointers. C and C++ both have a control flow statement such as if-else statement, switch statement and loops, which we are also using in the project which I made. After that, introduction to IoT. So IoT, what do we mean by IoT? So IoT refers to the network of physical objects or things embedded with sensors, software and network connectivity, which are allowing them to connect and exchange data to the cloud. It represents a paradigm shift, enabling a seamless connection between the digital and the physical world. IoT has so many compasses like interconnectedness of everyday devices like connectivity, which devices are connected to the internet to communicate with each other and to exchange the data. Sensors are used to collect data about their surroundings such as temperature, humidity, motion or location or so many physical quantities. Data analysis. We can also perform data analysis from the collected data which are collected by sensors. Application, we are using Blynk application in this project which are enabling us to diverse applications like industries including healthcare, manufacturing and agriculture as well. If I talk about the architecture and the ecosystem of IoT, so IoT ecosystem comprises various components which are working together to facilitate data collection, processing and application. It also involves a complex architecture with so many of layers like, first of all, first layer is device layer, in which it includes sensors, actuators and other physical devices which are used for collecting and transmitting of data. After that, there is network layer, which is the second layer of IoT architecture. In this layer, devices are connected to the internet, which are enabling communication between different devices and platforms. Third layer is data processing layer. In this layer, it collects, stores and processes data from devices which are preparing it for analysis and decision making. Fourth layer is the last layer, which is the application layer. This layer provides user interfaces, dashboards and application for interacting with IoT data and functionalities. If I talk about the example of application layer, so in this project, the application layer has an application which is named Blynk IoT app, which is Android app on which I have used dashboards and the user interfaces for showing you all about the data that I made. If I talk about the embedded systems, so embedded systems are not so big concept, but embedded systems are specialized computers that are integrated into larger devices or systems to perform specific functions. They are used just for a specific task. They are found in wide range of applications from consumer electronics to industrial automation, transportation and healthcare to the agriculture as well. If I talk about the hardware components of embedded systems, so it consists of microcontroller, which is also known as the heart of the embedded system. After that, there is sensors and actuators. Microcontroller is a single on-chip computer which integrates a processor, memory, and input-output peripherals. Peripherals are those devices which are connected to the computer, like input and output devices as well. Sensors are embedded systems which are rely basically on sensors to gather the data from the environment such as temperature, humidity, pressure, motion or light. Actuators. Actuators are those components that enable embedded systems to interact with the physical world such as motors, valves or displays. Now I am talking about my project which I made during this internship. So first let's talk about the problem statement. So my problem statement is to create a IoT based home automation system solution. As you all know, the traditional home automation systems are often complex and expensive, which are making it difficult for the common household to adopt them. Additionally, many of these systems are not accessible from a remote location, which are making it challenging to monitor and control home application when away from home. Which I proposed, IoT-based home automation system is aims to address these issues by providing an affordable and user-friendly solution that can be accessed from anywhere of the world using a smartphone application which is derived from Blynk. And now if I talk about the tools which I used, so first of all I used the Arduino IDE, which is an editor compiler for Arduino board or many of the board which are used in IoT applications. After there is PixSimLab, which is a program simulator for simulating our project. After there is a null modem emulator, which is just for the connection establishment like local bridges and so more. After there is Blynk Android application, which are used for controlling and managing of the devices. And if I am showing you the Arduino, so just a second. So this is the home automation Blynk controlled, which is our code for the project, and it is showing in Arduino IDE. You can see it all. This is basically home automation Blynk controlled code. In this, we have implicated Blynk template ID, name, and authorization token as well. So this is the how Blynk Arduino IDE looks like. After that, PixSimLab. So I'm showing you PixSimLab. Where is PixSimLab? This is PixSimLab, in which we can see this is an Arduino Uno, which we can select from here. I have selected the Arduino Uno already, and it is a microcontroller which is at Mega 328p. And this is all. And after that, if I talk about the null modem emulator, so it is a null modem emulator, and we can see it all that I have already established a connection between COM6 and COM7 of local bridge. And yeah, if I talk about the Blynk Android application, then if I show you, then just a second, I will show you later on. If I talk about the IoT based home automation system requirements, so the first, if I would like to tell you all that this requirement has been broadly classified into three parts. The first part is garden light control. In this, I am taking the input from the LDR sensor and processing the LDR sensor value, which are based on LDR sensor, and varying the brightness of the LED, which resembles controlling garden lights based on the availability of sunlight, and the output is garden light. And the second part is temperature control system. If a temperature control system consists of a heating resistor and an LM35 temperature sensor and a cooler, which resembles the temperature control system at the home. In this, I am reading the temperature from the temperature sensor, which is LM35, and displaying it on the CLCD. And after that, I am controlling the temperature of the system by turning on and off the heater and cooler through the Blynk IoT mobile app. In this, I am taking the input from temperature sensor. After that, this concept is also classified into three mini concept or sub concept, which is the first one is cooler control system, and the second one is heater control system. Third one is threshold temperature control. Then threshold temperature control. If the temperature is more than 35, then it automatically turn off the heater and send the notification to the Blynk IoT app and display the same on the CLCD. The third part is water tank inlet and outlet valve control. In this, I am taking the input from the serial tank of PixSimLab, which is showing in the PixSimLab, and the processing the and reading the volume of water in the tank and displaying the volume of water on the gauge widget and the CLCD on the PixSimLab and the Blynk IoT application. In this also, this concept has been also classified into three sub-concepts. The first one is inlet valve control, second is outlet valve control, and third is threshold water volume control. In threshold water volume control, if the volume of the water in the tank is less than the 2000 liters, then it automatically turn on the inlet valve and send the notification to the Blynk mobile app and display the same on the CLCD. After that, this is my output which I got from the LDR sensor. We can see all that above this there is LED and there is a three part. If the LDR logic is high, then the LED is on. If the LDR logic is low, then the LDR is off. And if the LDR logic is not is in middle, so it is its brightness is low. After this, this is the temperature and water control system. In this, in first part, temperature and water volume is showing on CLCD in PiximLab. After that, right side image is showing the temperature and water volume on the Blynk mobile application. In this, cooler inlet valve is open on the left side, which is shown on the CLCD in PiximLab, and in the right hand side, cooler inlet valve is open, which is also shown in a Blynk app mobile application. In this, heater and outlet valve is on, which is shown on CLCD in PiximLab, and on right hand side, heater and outlet valve is on, which is shown on Blynk application. This is the final image which I got. In this, we can show there is a CLCD. In this, there is also an Ethernet connection port, which I will show you later on. And this is all my PPT, and now I am showing the demo. So if I talk about my demo show, we can 1 second. I already told you about that local bridge connection is established between COM6 and COM7 of virtual serial port of null modem emulator. And yeah, this is the code. This code has everything like template ID of Blynk, template name of Blynk, authorization token of Blynk application. Then I am also used so many functions like Blynk write, which is for cooler. After that, I am using a Blynk write for heater. I am using a Blynk write function for inlet valve, for outlet valve as well. And in this, I am updating the temperature reading on the gauge on the Blynk app. In this, I am updating the water reading on gauge on Blynk app. In this, I am turning off the heater if the temperature raises above 35 degrees Celsius, which is shown here as well. And after that, in this handle tank function, I am controlling the water volume above 2000 liter as it will turn on the inlet valve if the water volume is less than 2000 liter. In this, if it is equal to 3000 liter, then I am turning off the inlet valve. In this, I am in this void setup, I am initializing the LCD as INIT is for initializing the LCD. This is for oning of the backlight. This is for clearing, and this is for the home starting. And I am using the set cursor for setting the cursor at the point of CLCD. This is for printing home automation on the CLCD, and I am showing a 1000 millisecond delay, which is equal to 1 second. And I am clearing the LCD once again for showing the temperature and the volume, which you can show here. After that, I am using the Blynk begin function, which we can through which Blynk application can start. And in this, we are showing the temperature, system, CL tank, everything is set up. This I am initializing the set interval function, which is for update of temperature reading every 1 second. In this, I am initializing a temp string of string type, and in this void loop function, I am controlling the brightness control, tank volume, and the Blynk run. By this run function, we can run Blynk application starts, and we are calling the handle temp and handle tank function from here. And this is also the ldr.cpp, which is a C++ file. In this ldr.hex file, main.h serial tank, there are so many files which are just the functions here, which are just if I show you in.main.h, I am defining temperature gauge pin number V1, cooler V pin is equal to V0, heater V pin is equal to V2, water volume gauge V3, inlet V pin is equal to V4, outlet V pin is equal to V5, and Blynk terminal V pin is equal to V6. And yeah, this is all our code. And now I am taking you all to PiximLab. This is the PiximLab. This is a PiximLab. Now I am uploading the code which I already saved. Wait a second, I'm again uploading the code. So in this, we have to export compile binary, and after compiling, we can upload it on Pixim Lab. So now I'm coming here to Pixim Lab. One second. This is the spare part. Basically, I'm cutting it, and now I'm uploading the hex file, which is already stored on. You can see it all. The name. It's the same name as it is shown on here. So I am just uploading it, and yeah, if I on the in spare part, so you can see it all. It is showing the home automation first. After it is showing the T, which is for temperature, and V is for volume, and you can see it all. It's an Ethernet connection port, and if the yellow line blinks, it means it is connected to my mobile application. And yeah, you can see volume is not showing it here. Why? So I am showing you all. From tools, I am selecting serial remote tank, and from here I am selecting COM7. Why I am selecting COM7? I am showing you all. From file, I go to configure, and here already COM6 is configured. That's why I am using the COM7, which you already show in that. I am establishing a connection between the COM6 and COM7, which is just a port, virtual ports. And yeah, I am connecting it. And yeah, if I show you all, just a second, it can be connected from Blynk app. So 1 minute, I'm showing you all. So this is just for the showing purpose. You can see it here. If I on, so my device is online, which is whose name is Home Automation Emertxe Internship, and I'm clicking it here, and you can see it all. I'm offing it all, and if I show you all, here it is. So my inlet valve is on. You can check it all. My inlet valve is on. Let's wait for filling it. And if it fill above if it fill to 3000 liter, it will automatically off, and the message is shown below here. It automatically off, and after the water volume is 3000 meter, turning off the inlet valve. It is showing the notification on the CLCD and the notification bar as well. And now I am showing you if I am owning the heater. So heater is on. Here it is showing. Heater is on, and if it is goes above 35 degree, here you can see, and here as well, if it is going above so here we all can see, like if I on the heater, so the temperature is constantly increasing. Here you can see, and here you can also see, and it will automatically off after it will reach 35. So let's wait for it to reach 35 degrees Celsius. Here we can see the water volume is 3000 liter already, so it will off. Let's wait for it to reach 35 degrees Celsius. So it will reach 33 just for 2 minutes, 2 degrees Celsius more. Now it reached 35 degrees Celsius. So here the message shown, like temperature is more than 35 degrees Celsius, turning off the heater. And if I am on the cooler, so if I on the cooler, the temperature is constantly decreasing, and will go till I think 27 point something, which is the threshold value. And this is the max minimum value. So we can see like temperature is constantly decreasing. So I just on the off there. And in here, if I show you all that, if I start the outlet valve, so we can see outlet valve is start, outlet valve on, and the volume of water is also decreasing. And if it reaches 2000 liter, the inlet valve automatically on, and the message is shown here. The water volume is less than 2000 liter, and turning on the inlet valve. Inlet valve automatically on, and if it is 3000 it will automatically off. So here it is 3000, and here message also shown, water volume is 3000 liter, turning off the inlet valve. As we can see, there is some delay in updating of volume. So this is all our project. So this is all our project. If I show you all, 1 second, I will show you all a Blynk application as well. I made it on. One second. Here, this is the web view of the Blynk mobile application, which I already shown you. Here I use the home automation Emertxe Internship. In this also there is cooler switch, heater switch, inlet valve, outlet valve, temperature gauge, water volume goes, notification. Okay, and notification also shown here. So it is just the web view. So that's all from my side, and that's all from my side. Thank you all, and I'm signing off. Thank you all. Thank you all.